Alright, everybody. Today, we're going to do one more little experiment with never nesting. And for kicks and giggles, I'm actually playing some of my techno music in the background because I'm going to do a little coding here. And I got the dog right next to me, so he's snuggling in, about ready to have a hackathon. And for those of you who may be interested in what I'm listening to, in case you want to listen to it as well, it's Fakes and Morton Au, 7 C's. So that's spelled Phaxe and Morton Morten Granau, and 7 C's, and that is the number 7 and then C's. Calm down, buddy, it's okay. He's got the shaky shakes because, yeah, daddy's talking in the adult voice. It's okay, calm down. Okay, so now we are going to, calm down, buddy. I'm going to first try to write some code, not following never nesting, doing it kind of the wrong way. And I'm just going to try to do the simple thing of processing this file. And I've got a couple fake rules that I kind of invented here. I'm going to do this the way I really do it, which is I try to never touch the mouse. Little things in life. So make sure the file exists. Pretend that we can check for the size stuff. Create a dynamic buffer. Put all the files, contents into the buffer, return 0 if success. I'm going to probably change some of this stuff as we go. But basically, I'm trying to make sure that there's stuff that can go wrong so I can give demonstration of the badness of doing things on the good path to move the function forward rather than handling the bad path. And hopefully this becomes apparent. Now, I have to be honest, I haven't written code in the bad pathway, in the good pathway as the first path for some time, so it may take some effort to kind of get this right. And I'm essentially going to write this as C++-ish. And this is going to be some pseudocode stuff, so don't expect that this is actually going to really compile. And yeah, all the cool kids essentially code in text editors. Actually, the reason why I've got the text editor is Visual Studio wants to do too much auto-completion for me. And I was trying to figure out how to turn it off, and I then just gave up, so yeah. Anyway, so let's give this a shot. Again, this is the first path, and we'll just say this is the bad example. Not following the principles of never nesting. Okay, so this is what we're doing here, just to make it super clear. And yes, I still try to follow whoops. Yeah, I've got this new Kinesis keyboard. Let's see if I can show everybody. I don't know if that's this thing, super awesome. But I'm still kind of figuring out where, like, these middle keys I think are the toughest ones. Whoa, okay, yeah, all right. Everybody can see now. Okay, so now let's I'm gonna try to keep my music going. Okay, so let's write some code. Again, we're gonna try to do this the bad way, and I'm gonna try to include the stuff. It's gonna be hard to do this entirely the bad way, but we'll see. And I can't help but have these spacers. It's really hard for me to code without them, so you're gonna have to deal with these things. Okay, I think this is like min size equals 512. It ignores things that are less than 512. Okay, yeah, we'll just say this, and then int const. Oh, and I intentionally, right. I'm gonna invent some types. And this thing is like this or something. Int64t, something like this. Yeah, this isn't exactly right, but I'm too lazy to look this up right now. And the reason why I'm doing this, okay, so this is 1,000, this is million, this is a billion. The reason why I was doing this is I wanted to make it outside of the bounds of a 32-bit integer to make a point about how type information, especially sized type information, can be important when you get to certain capacities. So I intentionally exceeds the I think it's 4.2 billion unsigned int max. And these guys are, we could make them unsigned, but we're just, they can be signed. I don't think it's really a problem. Okay, yeah, okay, now we can get into here. Okay, so we're gonna again do this the bad way. So first thing is we're gonna say, yeah, okay, if in dot exists. Okay, so this is, oh, yeah, these lower keys get me all the time. The file exists. And then say, oh yeah, right. So yeah, we're going to do this guy again. And by the way, when I go into coding mode, we get, I suspect some of you are like this too, you get sort of these half sentences. So if you get a bunch of gobbledygook coming out of my mouth, it's mostly because I think the coding brain is different than linguistic brain. And so, and there's actually studies that show that the coding brain is separate from the language brain, which is why when you're coding you can listen to songs with lyrics, but when you are writing like an email or something, it's very hard to listen to songs with lyrics because they conflict with each other, but code does not, or at least according to some psychological study or neuroscience study that I saw. Okay, so we're just going to assume that we have this thing, which is our size. Oh, right, and this namespace needs a name, so we'll call this n never nest. Yeah, there we go. No semicolon after the namespaces, I don't think. Yeah. Okay. So now size is equal to, we're going to just assume that n has this size thing where we can figure out a size from the single call. And then we'll say if size is greater than or equal to, right? K min size is greater than, and size is less than or equal to K max size. Okay. And now I know some of you are probably already yelling, saying, well, you're not using the namespace. Yes, I get that. Okay. Oh, it doesn't do the Visual Studio thing. Okay. So we have the second one, and now, oh, I moved up a little too much here. Create a dynamic buffer, put it inside. Okay. So we know what the size is. Now we have to create this dynamic buffer, and we're gonna. Oh, I think I was supposed to say that it should go into some sort of vector or something. So we'll say place into std vector of char. I don't know. Sure. Okay, so. Oh, right. And so we'll have this. So now this stuff. Yeah, that'll work. Yeah, okay. Is everybody okay with that? And yes, if this was a header file, obviously using the namespace stood. Not necessarily like such a great idea. Okay. So now we're gonna do trying to do this dynamically. All right, okay. I'm gonna change the signature to std vector char. I'm gonna call this the input stir. Sure. I don't totally love this. I realize it should probably be an std, a string, but we'll just do it this way for the time being. Okay, so now we want to go in stir resize to size. Okay. Now this can throw an exception if it exceeds this. So we could try to have like a try catch block around this. But let's just let's skip that case and let's just pretend that there's a like a sanity check on like that we can just check the size essentially, and if it allocated itself, then the size will be the right size. Hopefully that makes sense. So basically we can do this check. We can say if in.stir.size is equal to this guy's size, then we're good, essentially. Yeah, makes sense. So this is the file that exists. This is, oops. Yeah, I can't hit that character. This is the size of the file is within our bounds, and this is the in stir vector can be resized to the size of the file. All right. Those are essentially all the things I needed to do, right? Oh, and then we put all this stuff in here. So we'll just assume we can do some magic here just to keep the example simple. And we'll say in stir and you could probably do there's a bunch of different things we could do here, but let's just this is not exactly right. I don't think we could do something this easy. It'd probably would be more something like, I always think I get these things wrong. Not. I'm trying to think if. I mean, you could do something. I realize these are terrible names. Yeah, I realize since this is a vector, we should probably be doing like a pushback on it. Okay. And then, like, I don't know. This would be something like, to deal with the space or the return or whatever is going to go here. Okay, this is sufficiently ugly, I think, at this point. I think hopefully we've made our point about just how not great this is. I definitely do not like this code. And on top of that, we have to do other stuff to handles when the file doesn't exist. Okay, I'm just gonna do placeholders here. This one's gonna be handles when the file size is out of bounds. Okay, that's right. Yeah. This is gonna be handles when the vector couldn't resize itself to the right size. And in theory, this should work. Hold on, give me a second here. So, while this thing's not... Oh, we can do one additional thing here. this? Okay. Yeah, okay. Alright, so we're getting rid of this because we decide we're going to do this the right way. But in the process of that, I'm getting a little... Oh, okay. My music's still playing the right stuff. We'll do one more thing, which is in .open. We actually open the file, and then here we're going to close the file. Okay. This is sufficiently awful in my mind. I already hate this function. Wow, this is bad. Look at this thing. This is just disgusting. This is so bad in my mind. And it's not even really complete because there was like an exception case that we ignored, and we're not even handling all the various things that we need to handle for these else cases. Like, what are we going to do here? What are we going to do there? What are we going to do here? So hopefully this code also makes you want to throw up a little bit. So now we're going to rewrite this in a less ridiculously bad way. And again, this, you know, I'm doing lots of cheats here. I gotta fix this. Yeah, sorry, it was just too bad. What is that? Okay. Okay. All right. Let's just take another look at this. Yeah, this is... So, I'm speculating this code is not perfectly correct, and there's a whole bunch of holes in it, but hopefully we get the point of what we're trying to do here. Okay. Now, let's rewrite this in... Oh, okay. I think I was supposed to return 0 if it worked. Okay, yeah. By the way, for some of you that don't have as much experience with the error condition stuff, usually the reason why 0 is the state for goodness is it's essentially the singular value that essentially captures nothing. So the idea essentially is that there is nothing to capture, and so therefore the error is non-existent. And we're just gonna exit out of this and exit out of this, so those things stay closed. Okay, so now let's... What happened here? So now let's rewrite this in more of a never nesting way. This is going to be hopefully much more exciting. Okay. multi-add vector? Whoops. Include vector. Okay, yeah, include a vector. Okay. And we got this thing. Okay. So I already know that if I get here, it's going to return 0, so I kind of start with that. Now, this is gonna, my heart is already singing about how much I love this. Okay. Okay. Oh, whoops. File less. If it's less than, yeah, right. So it doesn't need to be greater than or equal to this time. Okay. Oh, whoops. My bad. Okay. Okay. Now I need to actually go back a couple songs. Oh, can I go back? Oh, YouTube. What are you doing, guys? Oh, I hate it when they do this to me. Okay, hold on. We'll find it. I think we'll find it. Here we go. Yeah, okay. Cool. Back to our songs on repeat. Okay, so By the way, I like this check much more than I'd like this check down here. This is this. I don't like this. It's the wrong kind of check because it could be off by one thing where it allocates it, but it puts an extra one in the size, and so you really want it to be like this. But it feels a little strange, whereas okay, I guess I'm still making this mistake here. I don't. Yeah. Ugh. Yeah, I want to like break the rules here. Okay, I'm gonna break the rules. I really want to say this: if this thing size is less than, in size, that's what I really want to do. Because it could be equal to or greater than, and it's probably still fine. Like, and I know that it's supposed to allocate it directly to the size, but you know, I don't know. In my head, I imagine all those corner cases where you can like over allocate it and provide you're beyond fulfilling what the user has requested. So you're adding like reserve capacity. And for those of you that know what I'm talking about, this makes sense, and those of you who don't, probably doesn't, but I'm just going to keep going. So here we'll okay. What was the call I invented? It's like add white space. Oh, I'm not supposed to do this. Okay, I won't do that. I'll actually rewrite that code in string. Okay, yeah. Did this slightly different, where this other one, I know that I allocated this inside of this. Yeah, like I can explain this in a second. Let me do this and finish this other code, and then we'll come back to this. Okay, so while that thing's going on, I'm going to do this. And then we're going to do for int I equals 0, I is less than in string dot size plus I. And then we're going to do in vector okay. Push back. Okay. It's vector, okay. Close the file. Turn no error. Okay. Here we'll just say Okay, now as far as this string, the thing is that we're going to reset this. Hopefully I got these arrows going the right way. I always get this wrong. Because I think it's pushing into it, so it's, and then when it's output, it's pushing to the output. I think this is right. How did I have it down here? Yeah. Well, we can leave in the comments that I got it backwards, but I think you all understand what I'm trying to say. Coincidentally, from a pure mathematical perspective, there is actually a much greater than operator and a much less than operator. So, like you have if A is greater than B, you also have an operator that's if A is much greater than B, and then if A is less than B, and you say if A is much less than B. This actually exists. But what's interesting is I don't think that they have any precise mathematical meaning, but they are actually mathematical operators, if you can believe that. Strange, right? It's a good example of hyperbole in mathematics, and I think part of the reason why nobody really uses it is because what does it mean? What does it mean? What's the difference between these two? 2.7? 10 million? Who knows? Nobody knows. It's strange. Meaningless in some sense. Yeah, don't like it. I've actually even seen some research papers that I've reviewed try to use this, and then they'll use it like, oh, it's an order of magnitude bigger, and so that's what it means. And it's like, okay, who decided that? You? And what if the next person thinks 2 orders of magnitude is the right definition? Like, again, it's just, that's a bit strange. So, but I want to mention that because these stream operators, they actually do have a mathematical meaning, or they are a mathematical operator. Okay, so let's just double check this now. We've got using the n-never-nest namespace, we check to see if the file does not exist, then we get out. If the file size is less than the min size, we exit with the less than min error. We have all these types of errors. If the file is greater than the max size, then we return with this thing. If the vector, I always get hung up on whether this should be together like this. I kind of feel like operations should be separated from control expressions, control structures. So, but anyway, so for this in vector, we try to resize it, and in theory, this would probably throw an exception if this fails. But in this universe, we're going to pretend like we can just check to see if the size is less than this thing. Again, we could do this check here, see that it's not equal to this. That's fine as well, but I think this is like a little bit better because it could be in this universe that you allocate beyond what you're actually allocating for. There's like a +1 for the null character or something. So that's why this less than is a slightly better version of this not equals, at least in my mind. Because if it's slightly more than what's needed, like when it does this resize, this code will still work, right? And in fact, we can even add something like right here that would do like add termination character to in vector. We could do that right here, and then terminates whatever this huge string is, and then if it's over allocated, there's no problem. So hopefully that makes sense. That's why I didn't like the way it was before, because it's just yeah, this is just a strange check, because it's really anything that's greater than or equal to the size would probably work. And this is kind of what I mean about, like, really, in my mind, senior developers, is they're thinking more than just the cases of, like, they're almost like rewriting the specifications for things as they're going through it, realizing that it's not quite right, which is sort of what I've been doing with some of this stuff. So anyway, I think we mostly have the core elements now. We open the file. Oh, right, and this thing, this was this string that I potentially was adding it before here. The upside of adding it inside of the while loop is that its destructor gets invoked every time you iterate on this, because you actually kind of exit out of the scope body inside of this, and then you re-enter it on subsequent invocations. And so, as far as I understand, and so it literally is destroying the string each time it gets to the bottom of that while loop. So for example, in this case, once it gets down to here, as soon as it hits this close bracket, it'll walk back up to this point. It'll do this check. Well, essentially, once it gets to this point, it will then invoke the destructor for in-string. This will be properly destroyed, and then it'll check this. If it goes again, then it'll reconstruct this and then do its thing. Okay, so this essentially guarantees that each time you're doing like cleanup or whatever with that string, and then it's reconstructing it on subsequent calls. This other version, this is slightly more optimized, this is slightly more performant, because it's constructing the string out here, and then each iteration it keeps that string in memory, and it works because you're resetting the string each time you perform this in operation. This reading from this if stream. So in string can be whatever it wants to be. It'll be rewritten once you get to this point, and then it's fine. Oh, and this was the line I was getting rid of here. Okay, so then we walk through the in string size, and then we push back that stuff to our vector, and then we add whatever the white space is for this in vector. We do this termination if we need it. We close, and then we return no error. Great. And what you'll notice here is that, at least in my mind, this code, which is 35 lines of code, about 35 lines of code, is nearly never nested. It's nearly never nested. It is just because we get to this. But this is the only really additional scope. And even for the ifs, I wouldn't really consider these additional scopes because we don't have curly braces and they're just exiting operations. I would also consider this for loop not an additional scope because, again, no curly braces, and it's just iterating and then being done. But this while loop, we do have a few things going on. Now you could rewrite this to be something like this. And then from this, you now are at like a single level of scope. So let me just process input. this. We got the tunes playing in the background here. Let's look at this for a second. This is if string. Yeah. Okay. Yeah, for the most part. We'll just say that this kind of does it. Okay, cool. So now we did the reordering operation stuff, and then we extracted this out. Now, in fairness, we could have done this for this other guy. So we'll just pretend that this thing gets done here as well. Okay, but even with all of that, it's my view that this is approximately now 20 lines of code. And it reads essentially serially, and it's essentially one level of scope, this whole function. And in fact, I'd probably do this. Yeah, I'd probably do that. Yeah, I'd probably do that. This feels a little cleaner to me. Because you open and close the file in the same space that it's actually doing the reading. Although admittedly, like this stuff possibly opens it. I don't know. There's some hand waving here because this is a little bit pseudocode-ish, but hopefully now we can see sort of in a clear way what the never nester concept is that this code, which now basically reads just serially, like if the file doesn't exist, exit. If the file is too small, fail for too small. If the file is too big, fail for too big. Then try to resize this thing. If the resize didn't actually do the resize, fail for not resizing. Then if all that stuff passes, we know now we're in like all the good state, and so just do the good thing. And the good thing is just process the input and then return, yeah, it all worked. That, in my mind, is significantly easier than this. This, in my mind, is garbage. This is way too complicated. There's all of this scope. And notice that while we can yank out like this while loop and the in fact, you know what, we'll even do it. We'll do it just to be fair. Okay, there, we're being more fair. But notice that these other things, at least to the best of my knowledge, and I need to run now real quick, bio break, so I'm a little bit expediting faster than maybe I'd like to. But the point is that these else's just have to do stuff. And it's just so kludgy. There's just so much nonsense here. Like, look at all this. It's just so, I don't know, amateurish. And I guess admittedly, we can probably yank this and then say, you know, just do the just do the return. The we have to match these, so this would be return the we didn't allocate the buffer, so we could drop this and just say, let me just actually drop it in so you can see what I'm trying to say here. Oops. Yeah, this Kinesis keyboard, I'm still... See, I try to be fair. Even when I'm trying to make a point about another thing, I'm still... Yeah, see, now this one's tough because in this other one we checked both cases, and so this one we have to recheck to figure out if it's smaller or larger. Otherwise, we just... Yeah, we can't say that. So there would be more work to do here. We can't just return a single thing in this case. And then in this case, we could. We could just say that the file doesn't exist. So this would be no file. Oops. Yeah. Wow. Oops. Yeah, I'm still learning my Kinesis keyboard. I could have just typed this, but it's more fun this way. Okay, there we go. So I still think that, and notice that we can't do this for this else because we need to be able to check between the boundaries of this. I still think that this code is significantly worse than this code. That's my personal belief. Yeah. So with that, I think that we will adjourn for this podcast, but stay tuned because next time we're gonna, I think, go beyond Nevernester. We might go back to world-class traits. Who knows? Okay. Thanks, everybody.